Hi Year 12s, welcome to your last lesson on finance, and today what we'll look at is what we call compound interest investments with additions, or an annuity investment. So basically the way to think about these, suppose you have given or you have some money invested in an account that pays compound interest. What you're doing is to increase the rate at which your investment grows. You decide to add to your investment by making additional payments. Okay, so we have seen something like this already, which is compound interest investments, but we haven't seen the additions part. Okay, so what we've been doing is slapping in an initial amount and then letting it accrue interest. But this one adds this additional thing here of, okay, we're investing some money, but this time around what we're going to do is continue to top up the account with additional payments. Okay, so when we're doing this, we model it using the following recurrence relation, where V0 is the principal. Okay, so this represents the principal, the amount invested, and the next term in the sequence is generated by looking at the R value here, which is the adding the interest and the original amount, plus whatever the additional amount that I'm going to add each week or each month or each year. Right, let's see how it looks in some examples. So Nor plans to travel overseas when she finishes her VCE. She's already saved $12,000 and thinks that she can save an additional $50 each month that she plans to add to her savings account. The account pays an interest rate of 4.8% per annum compounded monthly. Model this investment using a recurrence relation. So we're going to go V0 equals, and that's the initial value of the investment, that's 12,000. Vn plus 1, the next term in the sequence, is generated by doing, now the R value is based on this 4.8, so it's going to be 1 plus 4.8 over 100 times the number of times we do this, which is compounding monthly, so it's times 12, or 4.8 over 1200. So let's type that into our calculator. We've got 1 plus 4.8 over 1200, and we get 1.004 as our R value, times the previous value. So it's interest, which is the 0.004 part. 1 is whatever it was originally, and what we're going to do is add $50 each month, so it's plus 50. So we're not removing it from the account, we're actually adding it on top of the interest already that it's given to us. So that's the recurrence relation. All right. Jacob invested $20,000 and made regular payments to this account of $2,500 per quarter. If he was offered an interest rate of 12% per annum compounding quarterly, how much is in the account after 6 payments and 4 years? All right, so let's go into Financial Solver for this one, because this is beyond we could do this with a recurrence relation for 6 payments, but not really 4 years. That would be 48 lots of the enter. So let's use Financial Solver. So we're going to go menu, 8 and 1. All right, so let's just draft our ideas down. So it's N is the number of periods, which is 6 payments. So we're going to go 6. The rate is 12%. The present value, so he invested, which means that's an outgoing, okay, which means that's given to the bank. So we're going to write that as a negative. And made regular payments to this account of $2,500. So this is a payment from Jacob to the bank as well. So this is also going to be a negative. And that's the confusing thing, is often the payment has been the reverse sign of the present value with Financial Solver. All right, we want to know what the future value is, so that's the unknown. And PPY is, it's compounding quarterly. All right, so that's going to be 4 times a year and 4 times a year. Alrighty, so let's just type it in. So we're going to go 6, 12 on interest, negative 20,000, negative 2,500, 4 and 4. Future value is What does that say? Let's move the cursor. 40,000 and $52.10. $40,052.10. All right, let's do it after 4 years. So 4 years means 4 lots of 12. No, it doesn't. It means 4 lots of 4, which is 16. Why is it going to 12? No, that's the interest is 12. I was typing that in the wrong square. Good one. 4 times 6. Right, and let's get the future value again because all of the other conditions are exactly the same. Okay, so the future value is there. Seems like a lot of money. Yeah, makes sense. Lots of $2,500 repayments. Okay, so let's write that down. So our N is 4 years of quarterly payments. So 4 4s are 16. That's 12. That is still what I drop down, and that is still what I pay, or Jacob pays. Future value is what we want, and 4 and 4. So it's going to be 126,722.0 was it 6. There it is. Alrighty, let's keep rolling. Sam invests $170,000 initially in her superannuation fund. So this is her retirement fund, and then drops in another $950 each month to her account. Currently, she has this interest rate. After 10 years, Sam decides to increase her payments to this. The account still earns the same interest, compounding monthly. How much is in the account after 30 years? Right, so this is a condition change problem. So let's just see what's going on here. So Sam invests $170,000 initially. So that's PV is negative 170,000. Now remember, she's giving that to the bank. That's an outflow. The contribution is $950, so that's also an outflow from Sam to the bank. Interest is 5.3, and she's doing this monthly. 12. Okay, so the future value is what we want to know. Okay, and how long? It's after 10 years. All right, so what we're going to do is work out the future value after 10 years. That's 10 lots of 12. Okay, over to Financial Solver again. To the top, please. So that's going to be 120, 5.3, negative 170,000, negative 950. That's what we want to know. Change that to 12. Click on FV and update. So the future value after 10 years is going to be $438,391.82. Okay. All right, so let's now, and that would mean, see how it's positive? That means that's what the bank would give you after 10 years. So after 10 years, Sam decides to increase her payments to $1,200 a month. Okay, how much is in the account after 30 years? All right, so that means that we've run the normal one for 10 years. That means we've got 20 more years to go at 12 times a year. They said in the question that the interest rate is the same. It's still compounding monthly, so 12 and 12. The payments have gone up to $1,200. So that's an outflow because she's giving that to the bank to invest. Now, in theory, what would happen? See how this is positive? That means the bank would, in theory, give you this after 10 years. But what we're, in fact, going to do is just reinvest that back with the bank. So that's back to negative 438,391.82. And again, what we're after is the future value there. All right, so Again, over to the calc. What I'm going to do is grab this figure here and Control C, plonk it at the present value with a negative sign out the front, shave off the decimals until there's 2 decimal places. The payment has gone up. What's happened there? Whoops. To negative 1200. What happened here? 391.82. That's weird. Pausing the video to find out what on earth is going on there. Okay, yeah, so work that out. That was a problem with my float settings. So I've just gone in and changed or updated that. So let's just continue this problem now. So 91.82 is the value there, which I'm going to grab again. So Control C that, paste it over here, and the payments, that was gone up to 1200, 20 times 12 is the number of times we're doing it. So I'm just entering all those in again. Let's just check everything is correct. Okay, let's get the future value, which should have gone up significantly. And it certainly has, because she has got over $1 million, I think. So future value 1,773,107 106.79, which rounds to 80. So $1,773,106.80 is what is in her account after 30 years. So an impressive total. Okay, so we can also represent annuity investments in these things called amortization tables. So what we'll do is have a look at how this works, and it works a little bit differently to the ones we've seen. So payment made is obviously going to be $2,500 there. And what happens is, on the payment, interest is earned. So whatever the interest rate here is, it's 12%, okay? And then the principal increase is going to be the payment made plus the interest earned. Now this is different from loans, which the interest would be removed from the payment to represent how much is knocked down off the principal. So this time here, the payment and the interest both add to whatever the investment was. So let's work it out. So this one here is, we're going to go back to our calculator. And I know it's 12 over 100 times 12, which is 1,200, times this figure here. So 47,556.24, and I'm expecting somewhere in the vicinity of $1,400. Which is completely wrong. Have I left out? What have I done wrong there? 12% over 100 times 12. Oh, compounded quarterly. Good one. Okay, so it's compounded quarterly. So this should be, let's edit that. To 100 times 4 instead of that amount, and that's better. 1426.6869. Okay, so the calculation for this one was 12 over 100 times 4 multiplied by the previous balance of the investment. Okay, this one here is how much the principal increases by, which will be the payment plus the interest earned. Okay, so it's going to be these two added together. All right, so let's do that. 2,500 plus 2189.03. And again, it should sort of fit the pattern. 4689.03. Certainly looks like it. All right, this one here, what we're doing is working out the balance of the investment, which means that all we're going to do is add the principal increase. So it's this amount here gets added to whatever was previously in the account. All right, so that's going to be 5123.83 plus $87,460.92. So this is $92,584.75. So there's our amortization table, and there's the solution if you wanted to check. Alrighty, let's do a couple of questions. So Sarah invests $5,000 in a savings account that pays interest. All right, so this is clearly Financial Solver. Let's go back over to Financial Solver. Okay, invests means she gives the bank. Interest rate is 3.9. Compounding quarterly. At the end of each quarter, immediately after the interest has been paid, she adds 200 to her investment. So that's the payment. It's 200. Now, after 2 years, so that's 2 lots of quarterly payments. That's 2 lots of 4. Let's change the PPY to that, to 4, and we'll work out the future value. And there it is there, 7,059. Okay, so let's note those things down. So it's N, I%, PV, PMT, FV, PPY, CPY. So N was 8, I% is 3.9. We give the bank 5,000 in addition to $200 of quarterly payments, and the future value is unknown, and that one's 4. Okay, Ken has borrowed $70,000 to buy a new caravan. He'll be charged at an interest rate of 6.9% per annum, compounding monthly. For the first year or 12 months, Ken will make monthly payments of $800. Find the amount Ken will owe on his loan after he's made 12 repayments. Okay, so 1 mark only. So let's go, N is 12. Interest is 6.9. Bank gave him $70,000, $70,000. And he's giving the bank payments of $800. This happens 12 times a year, and let's just see how much he's owing on the loan. Okay, so there it is there. So we'll go N, I%, PV, PMT, FV, PPY, CPY. Okay, so the number of times is 12, 6.9, present value, bank gave me 70,000, yay. PMT, I give the bank 800. Future value is unknown, doing this 12 times. And the answer, which is all you need to provide, is Ken owes $65,076.22. Any rounding? No, that's it. Okay, what's the total interest that Ken will have paid after 12 repayments? Okay, so for this one here, we know that he owes this amount, so $65,076.22. So what we're going to do is add all of the payments that have been made, which is 12 lots of these repayments, 12 lots of $800. So I'm going to jump out of Financial Solver. 65, should have copied that value, 65076.22 plus 12 lots of 800. Alright, equals 74676.22. So notice that I looked at the future value of the loan after 12 payments, and it says that I owe this much here, or Ken does. So what I'm going to do is put all my payments back on, which returns me to this value here. Now notice that it doesn't return me to the 70,000 I borrowed, and that's because I've paid interest. How much? Well, it's this figure here, 74676.22, and we're going to remove the original $70,000, which gives us, it's a fairly easy one to do without a calc, 4676.22 interest. All right. After 3 years, Ken will make a lump sum payment of an amount in order to reduce the balance of his loan. This lump sum payment will ensure that Ken's loan is fully repaid in a further 3 years. Ken's repayment remains at $800 per month, and the interest rate remains at 6.9 per annum, compounding monthly. What's the value of Ken's lump sum payment? Okay, so what we're going to do is work out 3 years from start. Okay, so let's go back to Financial Solver. Okay, so we've got N I%, PV, PMT, FV. Okay, so we're going to do 3 lots of 12 at an interest rate of 6.9. The loan was 70k, payments was, what was it? 800, I think. Yep. The future value, that's what we're trying to find out when we're doing this 12 times a year. Okay, so let's change that, which I think is the only thing I need to change. 3 12s are 36. Okay, so basically he still owes $54,151.60. Okay, so that's what Ken owes. All right, now what we're going to do is work out the second part. So what's the value of his lump sum payment if he wants to pay down the loan in a further 3 years, still only paying $800 per month? All right, so this one's tricky, I%, and this probably would have been the last question in the module. All right, here's what we're going to do. So it's the last 3 years, so 3 lots of 12 payments, 6.9. Now, here's the slippery thing that we're going to do. We're going to set the future value to 0, which means that we pay down the loan. We're going to set the payment at 800 a month. And we're going to do this 12 times a year. And what we're going to do is work out the present value. So that is, if the loan was finished, what would the value of the loan be if I kind of go back in time 3 years? This is really what it's saying is, okay, if I was making payments of 800, terminating 0 under these conditions, what would it have been to pay it down? All right, so all we're going to do here is set the future value to 0. And I think all we have to do is hit present value. Yeah. Okay, so that means that our present value is 25947.76, I think. Yeah, 76. So that basically means that I'd be, or the bank would be giving that amount, okay, or that's the amount still owing to the bank, okay? Now, at the 3 years from start mark, the future value was this. This is how much I owed. To terminate the loan, I need this amount here to go down to that amount, which is going to be the value of the lump sum payment. So to work out the lump sum payment, all I'm going to do is 54151.60, subtract this amount here, 25947.76, 947.76, and that equals so 54151.60. Take away Control V. Oops, probably didn't copy it correctly. Take away. That's an equal sign. Take away 25,947.76, which basically says the lump sum payment is 28203.84. Says round your answer to the nearest dollar, so therefore 28204 is the payment that's required. Alright, and there it is, 9G, 1 to 8, and Friday's lesson will be one that you can work on the chapter review, so good luck with all of that.